Amaya is the last speaker, so whenever you are ready.
Okay. Good morning. My name is Amaya Holmes, and I am a sophomore at Savannah State University majoring in computer science. And for my research project, me and my mentor investigated to see if wells in northern Louisiana held grounds for any geothermal potential in those wells. Before we dive into everything, let me provide some background knowledge on some key things. Geothermal energy is basically heat that comes from within the earth. Water and or steam carry the geothermal energy to the Earth's surface. From there, the energy can be harnessed to generate clean electricity. However, for this to happen, a region with high or medium temperatures resources is needed. So how these plants work is fairly straightforward and simple. So hot water is pumped from deep underground through a well under high pressure. Eventually, when the water reaches the surface, the pressure drops, and as a result causes the water to turn into steam. Then the same steam turns a turbine, which is connected to a generator that produces electricity. The steam then cools off in a cooling tower, condenses back to water, and the cool water is pumped back into the earth for the process to happen again. There are a few geothermal plants within the US, and with these few, they reside exclusively on the western side of the country. This is primarily due to the fact that the most active geothermal resources are usually found along major tectonic plate boundaries, and one of the most active geothermal areas encircles the Pacific Ocean, which is the Ring of Fire. However, we have seen that there are large spots that hold geothermal potential in eastern part of Texas, along with the northern portion of Louisiana. So, what makes geothermal so special, and why would Louisiana benefit from it? Geothermal energy is clean and sustainable energy. These plants impact the environment very little, and this energy can be extracted without burning any fossil fuel. It's also a constant source of energy that just keeps on going. While energy such as wind and solar are also clean, they depend on certain factors, like, for example, how solar energy needs the sun to be shining and wind energy needs wind to be blowing. The only way for geothermal energy to stop producing or to be depleted would basically be for the Earth to be destroyed by the sun, which hopefully won't happen for another billion years or so. Also, they require very little land. They use about 1 to 8 acres per megawatt, while something like a nuclear plant ranges from 5 to 10 acres per megawatt. It's beneficial to the local economy and also provides employment opportunities. This is a $1.5 billion per year industry, and has directly and indirectly provided between 12 to 27,000 jobs. Lastly, this energy source is safe from surface influences. Louisiana is in a region that experiences a lot of hurricanes. So since geothermal energy comes from the ground, this energy source can't be wiped out by a hurricane and other elements of that sort. When looking at this map, we can see that there is a large spot in Louisiana, which is a very promising location. So for this project, we investigated if it was possible for northern Louisiana to set up a geothermal power plant in certain areas, essentially meaning do some of these wells meet ideal conditions. Over the last two months, I spent learning about geothermal energy and the processes of how these plants work. I had no prior knowledge to Python, and I spent time learning that along with refreshing my knowledge on stats, which allowed me to make my graphs and interpret what a lot of this data was saying and why was it important. There isn't an endless supply of research available on this specific area, but there is some. Thankfully, we were able to find a lot of raw data thanks to a thesis that was published from LSU's Department of Geology and Geophysics by a graduate student named Tessa Hermes. From there, we looked at 2 different parishes in Louisiana, Morehouse and Union. We looked at data from 37 different wells within the Morehouse and 23 wells in the Union. When looking at this data, we were looking at temperatures above a certain threshold along with the highest geothermal granite. Geothermal granite is the amount that the Earth's temperature increases with depth. Ideally, we want these levels to be high. We want there to be a high granite level at a low depth. We then put all this data into data sets, and from there we filtered out wells that had fairly high granite levels and reflected those into graphs. Let's look at the Morehouse. Again, we looked at 37 different wells in this area with a minimum temperature being 101.22 degrees Fahrenheit and having a max temperature being 257.0 degrees Fahrenheit, along with them having a max depth of 9,521 feet while the lowest reaching only 513 feet. These temps and these depths and temperatures are how far down was drilled and the temperature at said depth. Of these 37 wells, 10 had a geothermal granite higher than 29 degrees Celsius per kilometer. The lowest depth of these we saw was 1,452 feet with a temperature of 110.26 degrees, which had an incredibly high granite level. These, in this graph right here, you can see that these dots are bigger than, said these dots. These bigger dots are signs of geothermal anomaly, which is something we want. We want to drill at these spots right here. Lastly, let's look at the Union. For the Union, we did only look at 23 wells, which from here, which is a bit less than the Morehouse. From the data, we saw that there was a minimum tip of 101.39 degrees Fahrenheit and a max reaching 322.54 degrees. A major difference between these two was how much deeper the Union went. There was one well that drilled up to 13,655 feet. And from these wells, only 7 had a granite level that was higher than 26 degrees Celsius per kilometer. And again, we're seeing these big dots, which are the geothermal anomalies that we want. There are individual wells that are producing promising results from a bunch that we saw. The 23 wells from Morehouse and the 7 from the Union would be the most ideal. These wells will be an ideal location for a plant on a smaller scale. While they aren't reaching high temperatures like places in California, since Cali is along the tectonic plate, it is reaching temperatures that are still favorable. They would be great for communities by providing majority of electricity and providing economic benefits. This will cause there to be a less of a need and use of unclean energy. And I have my resources, and I do want to say thank you to everyone, especially my mentor and also Dr. Moreno for giving me this amazing and beneficial opportunity.
You are very welcome. Questions, comments?
So you mentioned 2 different parishes in Louisiana.
Yes.
Have you thought, is there any reason why you chose there and other potential parishes or states?
So when we were looking for or trying to focus on a region, there really wasn't much data on any other region besides just these 2. So that's what we decided to pick because it provided the most data for us.
And do you have something in mind in the future, other states or other parishes?
Oh, yes, of course. So I'm definitely invested in this project now because I really had no prior knowledge to any of this. I had no clue about any of this. So I definitely am invested in finding other areas that might not have any plants and just researching if it's possible for there to be future ones.
Thank you.
I have a couple of questions. I mean, the size of the dot, how do you determine that?
So the dot size was based on how high the linear granite was. So the bigger the dot, the higher the linear granite was for those.
Yeah, and how do you get the that linear graph? How do you, I mean, this is a measurement from the data set you got? Or?
I'm sorry, repeat the question.
Yeah, how do you get that linear graph?
Oh, it's the so it was provided for us in the thesis. The linear granite was also provided, so I just reflected those into the graph, into a graph.
Okay. Yeah, and my second question, why this is happening in Texas and North Louisiana? If there is no tectonic plate, why the?
Okay, so I picked Louisiana mainly because since the program is in at LSU, I figured it would be more of a ideal place to put it rather than looking at Texas.
Yeah, but why is hotter? Why the soil, the land is hotter here?
Oh, I actually didn't look into that. I'm sorry, I didn't gather any information on that specifically, but I can only assume that it's from, well, I don't want to say anything wrong, that's why. So
we don't know, so we don't realize.
I don't want to say anything that's wrong, but I'm not too sure why exactly, but I can look into that in the future.
Okay, thank you.
Mhm.
Any other question or comment? Okay, great.